So 8-4 or 8-5, I mean, we will do today. Then I'm gone for a golf tournament on Tuesday next week, so we'll do practice 8-4, or practice 8-5, I mean. Actually, I'll probably do the evens for this assignment because you get better information with the solutions. Doing that, so probably evens from 8-5 on Tuesday, and then you'll have a quiz for 8-5 on Wednesday next week. Okay, we'll have a little review time, so you can kind of pick up the pieces if you need to, and then we'll launch into that quiz, and I'm teaching you the last section of the year Wednesday after the quiz. Okay, so we only have this section and one more, that's it. Like probably the equivalent of maybe 20 more slides.
And then we don't have a quiz after the one on Wednesday?
You do not. That'll be the last one. Thank God, right? Hallelujah. Hallelujah. Okay, so write that one down. And we got to factor the denominator. Everyone's turned in their quiz, right? And, okay, are you going to work on it right after? Okay, you're good. You can have it, that's fine. So x minus 1 plus 2x minus 1 over this factors, right? So you can always do the cross to factor. So what multiplies 2 and adds negative 3? 2 and 1, so it's negative. Right, so we get x minus 2 and x minus 1. So now we need to add these things. To add two fractions, you must get a common denominator. So the way I think about this is I look at the both denominators. First one has x minus 1, second one has x minus 1 and x minus 2. So I think what's missing from the first fraction? X minus 2. So I highly recommend you write this in a different color because it'll stick out better and you're more likely to understand what the hell's going on. X minus 2, I meant to write, over x minus 2. So that's how we're going to get a common denominator. You can tell it's common because the denominators look exactly the same. It doesn't matter if the x minus 1 and 2 are in different order at all. So we got to distribute this x into the parentheses. And then when you add two fractions, you add the numerators, leave the denominator alone. So in the numerator we have x squared minus 2x. And then I write the other numerator, plus 2x minus 1. And then it's over x minus 1 and x minus 2. Exactly. Yes, we want to combine, but I'm just going to show you. So, oops. This thing went right here in the beginning, and then this one just goes right here at the end. Just helps you to know like where stuff came from. And then yes, we're going to cancel the negative 2x and positive 2x. So in the numerator we have x squared minus 1. Denominator we have x minus 1, x minus 2. Raise your hand, don't say it out loud if you know what this numerator factors to. Look around at how few hands are up. That's upsetting to me that many of you don't know that when I've explained it like 50 times. So this numerator is what? Plus 1 minus 1, thank you. Over x minus 1, x plus 2. So as soon as we combine the two fractions, do domain. So domain cannot be 1 and 2. What you got, Salon?
The second time you wrote it in the denominator, the first time it says x minus 2, but and the second time it's x plus 2.
Oh, it should be minus. Good job, Salon. Good catch. This one should be a minus right there. Thank you for catching that. So then, after you get the domain, it's just cancel. So then x minus 1 is cancel. So in our two-part answer kind of dealio, part 1 domain, part 2 is x plus 1 over x minus 3. So you've got to get a common denominator, multiply by what's missing. Write this one down. Couple addition ones, couple subtraction ones, and then one complex fraction at the end. So complex fraction sounds like it is not a misnomer. Complex, it is complex. We're going to do, the very last problem we're going to do is a quadruple decker fraction with addition and multiplication and division. Okay, so that'll be fun.
That sounds like math.
Math seems like that more and more as it gets harder.
Okay,
So what did you see up here? X. So we're going to take that out, and then we get, what you guys forget to do a lot of times is write that X in front of the parenthesis. So again, I'm trying to give you this info for next year as well. X minus 1 is what's left. So then when I look at the two denominators, what I just wrote, x times the quantity x minus 1 is 1. This first denominator is x minus 1. What's the first fraction missing? X over x. We're going to multiply by x over x, which means we will distribute into the parentheses. So as soon as we combine the two fractions, we're going to do domain.
Wait, so for the bottom, is it like just like that x parentheses?
Exactly. Yep. So this numerator will be x squared plus x over x parentheses x minus 1. And then I just have the minus 2 here as well. And now we do domain. So what's domain? All reals except and 0, right? Because we set x equal to 0 and x minus 1 equal to 0. That's another thing students forget frequently, so try not to.
Was that on the quiz too?
Yeah, there's one of those, yeah, with the, you had the one with the p's, it was p squared minus p or something like that, same thing happens. And we have the 1 as well.
Oh, no, I got that, all.
Okay? So what is this numerator factor to?
Negative 2 plus 1. No.
Other way around, right? Plus 2 minus 1. Good. X plus 2, x minus 1 over x minus 1. So let's say you're doing one of these problems on a quiz, or you're doing one of these problems in your homework, and you see nothing cancels, you probably screwed up. So check your signs, right, if nothing cancels. I mean, of course, they'll throw a problem or two at you where nothing cancels, just to screw with your head. But it's still worthwhile double checking. So then, final answer, part 1 for domain. All reals are x is not equal to 0 and 1. Part 2, x plus 2 over x. So you can't cancel those two x's in what I just wrote because there's addition in the numerator. If it were in the numerator x times x plus 2, then you could cancel the x. But it's addition, so you can't cancel anything. Unless it's the exact same talking about.
Oh, yeah. Those suck.
They're the best to grade, though.
Yeah, you guys just have to throw them through.
We had, I know, we had, I was in there with a science teacher to remain nameless, and back the old school Scantron, every time you got one wrong, you'd feed the horn, and it'd be like, if you missed them all. You'd hear that audible tone. So one science teacher was in there like running one after another, and it was like, like just one after another. And this particular science teacher said, the sweet sound of futures being flushed down the toilet. I was like, damn, that is dark.
Who's this science teacher?
I would not tell you that. It was really funny though. I'm not telling you that. Now you're like, I don't know.
Time frame when did it was?
It was a while ago.
Okay. I'm thinking Kathy.
I'm thinking Brandy.
Anybody who would say something like that is a big shit talker.
Who?
I would say something like that, but I even wouldn't say that. That's just not cool. Okay, so this denominator factors to plus 2 minus 2, right? X squared minus 4 is x plus 2, x minus 2. So second fraction by x minus 2 over x minus 2.
Wait a second. Oh, God.
So now, if I multiply 1 times x minus 2, nothing happens. So you don't really have to distribute that. But we're going to write the whole numerator, so x plus x minus 2. What's x plus x? 2x. Good. It's easy to mix it up between multiplication and addition, right? I just think of x plus x, like how many x's do you have? You got 2 of them, right? And then if you're multiplying, it's x squared. So that's the difference. Now, what does that numerator factor to? Like deja vu all over again. Plus 2 minus 1. And then what's domain?
All the real except plus or minus 2.
Excellent. And then just the plus 2's cancel. Bam and bam. And final answer, x minus 1 over x minus 2. So do domain once you combine everything. I could do domain here or here. Just as long as you do it before you cancel, you're good. Subtraction.
I'm running out of paper.
Just in time. So, I don't like when you guys subtract because you tend to make careless errors. So instead of subtracting, just like when you did polynomial long division, we did the 3 switches. Same thing, switch a negative in the middle to a positive, and then switch both signs in the numerator. Only numerator. So if you know you're a knucklehead and you're likely to make that mistake, switch both signs in numerator. And then you're obviously going to switch the one in the middle as well, right? So you need the 3 switches. Okay, so we need to do some multiplication here. What is that first fraction missing? Look at the denominator from the second one. Denominator for the first does not have what? 2. So we're multiply by 2 over 2. Again, different color is helpful. And then this one I have to multiply by x over x. Right, so we're going to distribute that x in, and we're going to distribute that 2 in. So the numerator becomes 2x plus 4. And negative x squared minus 2x. So when you have, like right here, I've got plus minus right next to each other. The minus always wins, right? Positive times negative is negative, so that's why it's a minus 2x right here, okay? And then this thing is over 2x parentheses x minus 2. So now we have everything combined, and we just use the denominator for domain restriction. So I set 2x equal to 0, and x minus 2 equal to 0 for the domain, which can't be 0, and 2 can't be. That's an annoying deduction if you forget to put the little slash through the equals. I will take points off for that.
Which way the slash goes?
Don't care which way the slash goes. All right, it's a good question. So the numerator is negative x squared, 2x's cancel, plus 4, over 2x, x minus 2. So how do we factor that numerator? Because you can. So a little side light off to the side with that negative x squared plus 4. So I can take out a negative 1 first. Then I have negative 1 parentheses x squared minus 4. Right, so if you see that opposite sign thing with like negative x squared plus 4, factor out that negative 1, and then x squared minus 4 factors to what? Plus 2 minus 2, good. So see, from that negative x squared plus 4, it turns into this over here, which, you know, some stuff going on there. So, domain, we already did. So, let's show this, negative 1, x plus 2, x minus 2. So as I've said all year long, this technique, where you take part of the problem and write it off to the side, figure out everything you can, and plug it back in, is a strategy you'll use for every single math class you take from here until you're done with math. So the only thing that cancels is the x minus 2. So then we'll distribute that negative 1 back in, and then we'll have the final answer. So negative x minus 2 over 2x. So that's your part 2 answer. Part 1 is where it's at. So remember, you're thinking about the quiz you're going to have this coming Wednesday. You're going to be doing the evens from this, so just have that mindset so you get the intense focus, because I won't be there Tuesday. But, like I said, I'll give you solutions. So one more of these, and then the complex fraction, and then it's notes time.
Homework time?
Yes, I mean homework time. I didn't mean that. So once you get to homework time, if there's like a quiz you need to retake or something like that, good to do it now, because after today, you're not going to be able to retake anything, except for the quiz today or Wednesday next week. But missings all due Monday at midnight. Yep.
What if you didn't do a quiz in the first place? Can you do that?
You can do it today.
And only today?
Well, you could actually do it online, because there should be a version posted, and just have it done by Monday at midnight.
Alright.
Okay? Okay, this bottom factors to what? Bottom of the second fraction.
X minus 2, X minus 1.
X minus 2, X minus 1, so we have x plus 3 over x minus 2. I'm going to do my 3 switches. Right, so the middle, the negative, so then we have plus negative x plus 7 over x minus 2 and x minus 1. So again, what are we missing from that first fraction? X minus 1 over x minus 1. So this one's a little more of a pain in the neck, because you got to foil this top, or you can box the top, whatever works for your brain. I like the rapid foil method, so the numerator I multiply the 2 x's to get x squared. I add the 1 and plus 3, so negative 1 plus 3 is positive 2x. Then multiply negative 1 times 3, and we get negative 3. And then we have minus 6x plus 7 over x minus 2 and x minus 1. So once you combine things, get domain. If you haven't written that in your notes yet, you should write that in your notes. Once you combine the two fractions, do the domain. Okay? So it doesn't matter that the numerator looks like a disaster right now, I can still do domain at the bottom. So x cannot be 2 and 1.
Let's put DI, please put D.
That's like a colon right there. Yeah. 2 and 1. And then we combine like terms in the numerator. So we can combine the positive 2x. The only mistake I see students making combining like terms is you forget to get the sign in front of the term as well. So minus 3 plus 7. So we end up with x squared minus 4x plus 4 over x minus 2, x minus 1. So again, with the numerator, if you need to do the cross, it's always fine to do that, right? I think it's good visually to see. And then what goes on the side? -2 and -2. Excellent. And then just x minus 2's up top. Some of you guys might be tempted to write x minus 2 squared. You're opening yourself up to some careless errors doing that, so don't do that.
But you do that, and then I just cross off the square.
The little squared, yeah. Honestly, that's how I do it. I just teach in a way that I hope will reduce the amount of careless errors you guys make. Because it makes me mad when I'm grading your stuff.
Gotcha.
X minus 2's cancel. Final answer, x minus 2 over x minus 1. Like that. So part 1 was way up there. Part 2 is down there. Really important, you're making the 3 switches when you subtract. You're multiplying by what's missing, right, to combine like terms and get a common denominator. I'm not doing that one. So, don't write these down. I just want to have a moment to talk to you guys about next year if you're taking pre-calculus. So if you're taking discrete, take a little mental mind break and just don't think about anything, right? If you're taking pre-calc,
What's discrete?
discrete is like topics in math, everything's open note. It's kind of like this year for you guys in math, whereas next year I'll be raking my juniors over the coals in Algebra 2, right? But like this right here, that's a test question in a regular year. Yeah.
Why would you do that?
Because it's fun. Because you can do it.
You wouldn't have done that.
Yeah, no, it wasn't me. So if I put a question like that on there, right, I'm only expecting like probably 5% of the students to get it entirely right. Okay? I expect many of you to get a lot of partial credit on it. You might get 3 out of 4 on that kind of problem. I know, I see all the eyes looking at me like I'm a crazy person, which I am. But you can get problems like that. Next year in pre-calculus, you will get problems like that. Okay? You will learn how to do it. Like, both Shero and Paloma are great at breaking stuff down. So you guys will be prepared as long as you're doing your work and everything. But I just want you to have that mindset switch coming in for next year. It's not to create a lot of fear in you guys. Like, as long as you're doing your homework and paying attention in class, you'll do fine, right? It is a lot to ask. And we will be asking a lot to ask, and next year I'll be talking to every student I have about that. Like, you guys, you better fasten your seatbelts for next year, because all of a sudden it's going to be regular school again, 7 classes every day. So if you're juniors, take the off periods, right? You have an 8-period day, you get a whole period for lunch, which is a bonus, right? So you get a whole period for lunch, and then juniors only have to take 6 out of 7 classes, so take that off period. Don't be crazy and take all 7. There's no need to do that, okay? Unless you want to graduate a semester early, then you probably have to take all 7 and maybe a class or 2 in summer school.
Or you're doing business.
But, Nate, question?
What are those events called again? What is our
Complex fractions, is that what you're talking about?
Yeah.
Or, yeah?
Yeah.
I feel like it's no.
What were those sites you mentioned that helped with that?
Khan Academy is the easiest and best one to use for any help in math. Okay? Khan Academy was so key when I took calculus in college. It was even around back then, and it helped me a ton. You just get a different explanation of the same topic, and sometimes it can confuse, but generally it's helpful.
Will this be on the quiz with this question?
Maybe. Okay, so you'll see this isn't as bad as you think. You just treat numerator, denominator totally separate. So we're going to have to combine, we're going to have to get common denominators here, and then add the two fractions. And then because it's, kind of a quadruple vector fraction thing, we're going to flip that second fraction and multiply in the end. But let's start going. So second denominator has y, first denominator does not. So I'm going to multiply by y over y. Second fraction has the y but doesn't have the x. So I'm going to multiply by x over x. Right, and then you can see the denominators are the same. They're both xy. So let's finish off that numerator first. So you get y plus x squared over xy. Second fraction. Second fraction. That's a y right there. This one is missing the y. The first fraction is technically missing the 1, but I don't have to write that because you multiply by 1, nothing changes. So this second fraction becomes 1 plus y over y. No big deal, right? Everybody can do that. This is a big fat divide, right? That's this fraction bar right here, is this division right here. So instead of dividing, we're going to multiply by the reciprocal. So we're going to take this fraction, y plus x squared, over xy. Now we're going to multiply instead of divide, right? I'm doing reciprocal right there. Y over 1 plus y.
Not that bad.
Right, it's not that bad. You can do it. Yeah, absolutely. You can hate it, that's okay, but you can do it. So then the only thing that we're not going to worry about domain with this because it gets more complicated than you want to deal with. Basically, x and y can't be 0. But this y cancels with this y, right, because it's multiplication. So we do not need a common denominator when we're multiplying. The other two y's. No, because they're added, right? These are multiplied, these ones are added, that's why you can't. I know, that's what can wreck people right there.
Yeah, that would definitely get me.
So in the top, you just have y plus x squared. In the bottom, you have x times 1 plus y. And then last step, we just need to distribute that in. Y plus x squared over x plus xy. X times 1 is x.
Yeah.
Right here.
Oh, that's a y.
X times y is xy. Right there. Okay? Alright, that's it. I'm going to stop this recording and save it.